Hello Algebra 1, Mr. Knight here again. Continuing on Unit 2, we're looking at Level 4, something called Distribution. And before we jump into this, I want to give you guys cupcakes. I do. I don't know how many to give you guys, and it kind of varies based off the class, because I have different class sizes, and sometimes you guys will show up, sometimes you guys are absent, so it kind of varies a lot, and so I want to create some kind of general way of figuring out how many cupcakes I need to get you guys. So we're going to do that today. And then our skills alongside that are distributing constants and variables, so numbers and letters, and distributing with fractions. We're actually going to figure out what that means, and then we're going to figure out what terms are. So let's see a layout of my class before we look at the cupcakes. Now, I know you're looking at this and you're like, dude, those desks, ha 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 ha, you can't draw Mr. Knight. Well, to that I say, I agree, but that's not important. What I can agree on, though, is that we like cupcakes and we need to figure out how many we can get. So, every day is kind of different. Let's say I have a certain amount of cupcakes, right? Let's call it C. It's like my we'll just call these cupcakes for right now. And some days it might be different depending on the day. Like this, let's say this row on this day has like 4 kids. And let's say this one has 3, right? There's one right here, one right here, one right here, one right here. There might be one right here, one right here, one right here. You get the idea, and so on and so forth. We'll say this one has 2, this one has 2, this one has 5, and let's say we have 1 lone soldier over here. So 4, 3, 2, 2, 5, 1, and I need to figure out like a good way to give out cupcakes. So if C represents my cupcake, let's write that down. And then I know, well, if I'm going to have like the total amount of people, right, I have to add them up, right? I got to get the total. So I probably want to add up my 4 students, add my 3, add my 2, add my 2, add my 5, and add my 1. Okay, and then if I'm giving out however many cupcakes, right, then let's say I'm giving out 1 cupcake, then I want to give it to these 4 students in that row. And then I want to do it to these students here. I want to do it here, 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 and here. I am distributing the cupcake love to all my students, right? So what's going on? Well, I know that 4 students are going to be getting a cupcake. And then I also know that there's going to be 3 more students that get a cupcake. And then 2 more, then 2 more, then 5 more, and then 1 more. Okay? So these are all the students getting cupcakes. And if I want to get the total number right, well, I'm going to just add them up, right? 4 plus 3 is 7, plus 2 is 11, plus 5 is 16, plus 1 is 17. So this gives me 17 cupcakes. All right? But you're probably looking at that and you're like, dude, why'd you go through all that trouble, man? You could have just added these up in the beginning, right? You could have. Well, let's see what that looks like. I would have got the same thing. I would have got 17 in here. And then it would have been multiplied by the C, so I get 17C again. But both ways work, right? I'm not wrong. I just kind of went about it in a different way. I'm getting like, yeah, don't attack me, man. Look, we did it the same. We got the same answer. I just did it a different way. So what's going on? Well, this is distribution, what I just did, right? I distributed the cupcake to the number of students. And in math, distribute means to multiply by each number or variable being added, right? To multiply each number being added in here, right? It's separated by parentheses. So basically, I can use this skill to kind of help me solve some problems and to rewrite expressions. Let's take a different look at this in a little bit, okay? Let's go to skill 1, which is distribute constants and variables. Okay, so if I gave you something like this, now it's super arbitrary, it's super random variables and numbers. How would I do this through distribution? How can I rewrite this? Well, again, I take my cupcake. I don't know what this is. It might be a cupcake. It could be an actual cake, a big boy cake. It could be all kinds of stuff. And I'm going to give it to whatever is being added or subtracted in here. So I'm going to give it to the W, and I'm going to give it to the positive 2. And really all I'm doing is I'm multiplying. So x times W is xw, and then 2 times x is 2x. And there you go. That is distribution right there. Okay, that's another way to see it. Let's see it with number 2. Now I'm throwing a negative in there. Does it matter? Yes, it does, especially with multiplication. So again, I take my cupcake, or whatever I want to call this, and I'm going to share the love. I'm going to distribute the love to the x, the negative y, the plus 1. 6 times x is 6x. 6 times negative y is negative 6y. And then 6 times 1 is 6. And there we go. There it is again, right? I gave the 6 to each of these. And by gave, I mean I'm multiplying the 6 to each variable or constant that's in the parentheses. Okay, that is distribution. That's all it is. Nothing crazy. I would like us to try one more. Let's try one more. Okay, I'll keep this guy kind of the side right here so you can kind of refer to it. But let's look at number 3 real quick. Number 3, now I have a negative t on the outside. That negative, that whole thing, does matter. I'm going to take my negative cupcake now. I'm going to give it to these 3 constants and variables. And what I end up getting is, well, negative t times 6 is negative 6t. And then negative t times positive x is negative tx. And then negative t times negative y is a positive, right? A negative times a negative is a positive ty. And there we go. I am done. Right? Notice I'm writing my constant out in front of my variable. So even though I had negative t times 6, that's the same thing as negative 6 times t. It really is. Okay? So try to get in the habit of putting your constant in front of your variables and watch your signs. They do matter. So now let's see with some U-try problems. I want you guys to try these 2 on your own. Distribute the following expressions and go. All right, we're back. Let's take a look at these. Okay? Again, I take my 3. I'm going to distribute it to each of these guys inside of here. So I'm going to get 3 times x, and then 3 times negative y is negative 3y, and then 3 times negative 5 is negative 15. And there we go. What about this guy right here? Okay. Again, I take the whole thing, including the negative. I go to each of these. So I'm going to get negative wx plus 7w. And there you go. Now, what we're doing too is, well, we are rewriting it. And why this is important isn't totally apparent right now, but it's going to become more apparent as we move forward. So just be patient with me. But this is a useful skill, and take my word for it. What we're doing is we're actually getting terms out of this. These guys are called terms. What is a good definition of a term? Well, term is variables and or constants that are multiplied together, and they're actually separated by addition and subtraction. So let's actually take a look at what that looks like here with another example. So if I had these 4 terms right here, right? These terms, they have constants and they have variables, and they're being multiplied. Remember, if our numbers and variables are chilling by each other and there's nothing like in between them, they're actually being multiplied, right? So this is 3 times x plus 2 times y minus 5 plus 1/4 times t times w, right? I can have a combination of constants and variables that can make a term. And the terms are all separated by addition and subtraction. You can even have just constants or just variables. Those are also considered terms as well. Okay, so it's another name for them, but term specifically is numbers constants being multiplied, or variables constants being multiplied together. Okay, now let's see distribution with fractions. Okay, our good old buddy pals, the fractions. Well, if I wanted to distribute this 1/4 to each of these guys, I do it the same way I was doing before. I take my 1/4 and I'm basically going to give it or multiply it to each variable or constant in here. So 1/4 times x is 1/4 x. 1/4 times negative w is minus 1/4 w. And then 1/4 times 3. If it helps, write it off to the side what 1/4 times 3 is. And put it 3 as a fraction as well. So you multiply the top and the bottom and you'll get 3/4 out of this guy. Okay? And that guy is done. How many terms do we have with this guy? We have 1, 2, 3. 3 terms separated by subtraction and addition. So we have 3 terms. Okay? Let's look at number 7. Now, let's say I have a fraction that's inside. Is that going to matter? Not really. Again, it's the same basic ideas of multiplying, right? I'm going to take my negative y, and I'm going to go to the x and the positive 3/4, and I get negative yx. Negative y times positive 3/4 is negative 3/4 y. How many terms do I have there? I got 1 and I got 2. I got 2 terms. Alright? And that's it. It's just now using a fraction. So if you're uncomfortable with fractions, we're just going to have to get some more practice with that because fractions are here to stay. They're not going anywhere. And they're not, they don't have to be horrible. Okay? Once you get the ideas down, they're not too bad. So now there's going to be some 2 you try problems. Okay? And I will actually keep this to the side so you can refer to it to help you solve these problems. Number 8. I want you to distribute this guy, and likewise, number 9, I'd like you to distribute. Something about number 8, keep in mind, we didn't do something like this, but I want you to use this idea of distribution to do 1/5 times 2/5. Okay, fraction times a fraction. I think you got this. And go. All right, we're back. Let's look at this guy. Or girl. I can't assume that this is a guy or girl. I'm just kidding, okay? 1/5 times x, 1/5 times negative y, 1/5 times 2/5. So I get 1/5 x, and then I get 1/5 times negative y is negative 1/5 y, and then 1/5 times 2/5. Again, if it helps, write it off to the side. Okay, we multiply the top, we get 2, multiply the bottom, we get 25. So this is plus, positive, 2 25ths. How many terms do we have? We have 3. 3 terms. Okay. Maybe you're starting to see the pattern that however many we have in here, that's however many we're going to end up with. And if you did, good recognition. And then number 9, we have a negative x times a negative y. That's just going to give you a positive xy. Negative x times positive w is negative xw. Negative x times 6/7, a positive 6/7 is negative 6/7 x. And we have 3 terms in that guy. So that's really the idea, is just I want you to be able to use this distribution method. It's actually a law in math. to be able to rewrite your equations and your expressions. We didn't work with equations in this lesson, but we eventually will build towards that. Have a good day, and be sure to look over the video again if you need a refresher and need to go over stuff again.